And we are now live with NASA Jim, is what we affectionately call you, but you are Jim Adams, and you are recently retired. But if I recall correctly, you were the Deputy Chief Technologist of NASA. What on earth does the Deputy Chief Technologist of NASA actually do?
Well, that's probably why I retired. Nobody could figure it out. No, actually, what the Deputy Chief Technologist does and what the Chief Technologist does at NASA is advise the administrator of the agency, the guy that runs the place, on the investments that the agency is making in technology to assure that we have the technology to do the things that we will need to be doing in the future.
And when you say technology, what sort of things are you referring to?
Oh, everything from new materials to new communications techniques to advanced 3D printing to rocket engines. It runs the gamut.
Wow, so that's quite a broad spectrum. And when you talk about technology, I mean, the whole space environment is built with technology. You have to utilize technology to gain results, to get feedback, to do research and that sort of thing. And obviously, over time, certain things that you were doing in the old days become outdated and new technology comes in. So how do you keep track of all the new developments on a regular basis?
So we have several ways of doing that, actually, and the public can actually watch most of it. There's a tool that people can sign up for through the NASA website called TechPort, and TechPort is a place where you can go and delve into any bit of technology that NASA is using and what we predict the future of that technology is and what the future need might be. So we know what the state of the art is. We know what the need might be in that area. Say it's advanced solar cells, and then once every 2 years or so, they update that database with what NASA is working on towards those new goals. So we know the state of the art. We know what we think we're going to need in the future, like being able to literally, it's amazing. We're now even thinking that we might be able to fly solar arrays all the way out to Saturn. I mean, Juno was the first to fly them to Jupiter, and now people are thinking, maybe we could get away with getting them all the way out to Saturn. That's amazing. So wow. We keep track of these technologies. And then as opportunities arise, either in terms of working with Congress or other agencies or developing new innovative techniques of working with the private sector, then the Office of the Chief Technologist kind of steps in and helps to guide that, as well as advise the administrator and his staff on whether or not this is a wise choice. And so that's what I did. But last thought is the chief technologist was my boss, and he worked directly for the administrator. I was the deputy, but the chief technologist they would come in on 2-year assignments from universities, like from Georgia Tech or from Cornell or from MIT. And so in order to assure there was some longevity, the deputy was always a constant person that was just sort of always there to ensure there's continuity, I guess is the right word, between the...
So what you're saying is that you were the wheelbarrow, and every 2 years they got someone to come in and push
me around.
But you were the one carrying all the bricks.
Well, maybe.
Okay. I understand why you retired. But I mean, when one looks at technology and the way the world works, if you go back, let's say, 2 or 3 decades, a shuttle launch was a big deal. Just to get a rocket up in the air safely and bring it back again was a very big deal. To build a space station was a big deal. Now it's meh. Elon Musk can launch a rocket tomorrow and land it tomorrow, the same day, and then launch it the next day if he wanted to, because he can reuse these things. I mean, from your perspective, do you see an exponential growth in the technology and the number of people who are jumping on the bandwagon and trying to bring all these new ideas and creativity and having access to all the tools that can produce all this technology at much lower cost? I mean, what is your view on all of that?
So I love the idea that space is open to everyone. And if it weren't for the investments that NASA and other federal government agencies have made in the development of space technology, companies like Virgin Galactic and SpaceX and Blue Origin would not be where they're at today, right? That doesn't mean that NASA has to be a player with them. It just means that we built a foundation that now people can go and innovate off of, right? Mm-hmm. And I applaud Elon Musk and SpaceX. And isn't it amazing that he's now been able to do something that NASA really didn't even contemplate, flying the first stage back, right? And capturing that. We had, reused a space shuttle, obviously. We had refurbished the casings for the solid rocket boosters on the space shuttle. But to actually fly them back, immediately after launch, that's an amazing feat. So,
I mean, when you saw that first landing, that must have blown your mind.
I got chills. Yeah, totally.
Were they multiplying?
Yeah.
And did you start losing control? So, I mean, here you've got a situation where technology is obviously advancing at a rapid rate. The race to get to space is heating up, because now it's not just a case of sending probes out to other planets. Now we're talking seriously about getting someone on Mars.
Oh yeah,
that's a big deal.
Yeah.
Did you ever think that was going to be the goal during your time at NASA?
I did. Yeah, because we've been talking about going to Mars since before we actually made it to the moon. That's how long NASA's been studying and contemplating and looking at Mars as possible next destination. So we're headed to Mars, and sometime in the 2030s we'll be there in my lifetime. So I think.
Do you reckon it might happen sooner?
Well, it's possible. If you take a look at what the plans that Elon Musk has, or maybe the plans that Mars One has, or maybe the plans that China or any other nation has. It's entirely possible that that somebody else will get there before NASA. I don't view this as a race. I view this as a collaboration, and that when the first person from Earth lands on Mars, they're landing for Earth. They're landing as a global initiative and not as a new sort of space race. A lot of people felt like we needed to find a new contender, to have some competition in order to well up the public opinion and that sort of thing. I don't think that kind of energy is positive. I think what's positive is people coming together to accomplish an amazing goal, which is, hey, let's go to Mars. Let's put an outpost on Mars. Let's learn what it's like to live and work and yes, even create families on the surface of another destination. So I think this is an amazing time to be alive and to be a part of something that's much bigger than any one of us.
Well, I mean, before we get into focusing on Mars in particular, you've been involved with quite a few projects where rovers or probes have been sent out to space to have a look at other planets. A couple of years ago, we didn't really know much about what Pluto looked like.
Oh, yeah.
And then all of a sudden, New Horizons comes along and gets to take some close-ups of Pluto. Was that a simple overnight project, or was that a long time in the making? Because as you know, Pluto it's not exactly round the corner for us.
No, no, and so there's a lot of depth in your question, Steve. The journey just from the launch to the flyby of Pluto, just the flight time took 9 years. Right,
9 years.
And New Horizons was the fastest moving object ever to leave the Earth.
How fast did it move?
Oh goodness. I'm sorry, I don't have the numbers memorized exactly, but
I mean, a ballpark figure.
I'll tell you, here's a comparison. It took the astronauts in 1969 3 days to get to the moon. The New Horizons probe crossed the moon's orbit in 9 hours.
So that is very fast.
So yeah, it's extremely fast.
But what was propelling it?
Just a big rocket that was underneath this little tiny spacecraft.
But of course, how does the rocket keep going for 9 years?
It doesn't. It coasts. The rocket pushes it really hard, and an object in motion will stay in motion unless it is acted on by an external force. And there are no external forces in space other than the sun's gravity.
Other than meteoroids and space debris. I mean, could that have been a major obstacle for New Horizons?
It was a concern once we got out to Pluto. That's a whole nother story. But the force, given the fact that today is May the 4th.
May the force be with you.
And with you. The force that was slowing New Horizons down was the sun. So the constant pull of gravity was actually, if you look at the velocity curve of New Horizons, it starts out really fast, and then over time it just exponentially curves down because of the constant pull of the sun on this little tiny spacecraft. And that, by the time we got out to Jupiter, we decided we would do this slingshot maneuver around Jupiter. That gained a tiny amount of velocity, a few kilometers per second or something like that, but it shaved like 2 years off the flight time. So it could have been an 11-year journey instead of 9 if we hadn't done that maneuver around Jupiter.
But now I know that my cell phone has awful reception in certain parts of my house.
Yeah.
But communicating with something that is how many kilometers away?
Oh. 3 billion miles. You do the math.
How many? 3 million or 3 billion?
Billion with a B.
3 billion miles. It's a lot. So I mean, if you think about it, if you think about it, how are you communicating to make this craft actually do the maneuvers that you want it to do?
So we've got some amazing support communications technology spread around the world in 3 positions around the world, one in Goldstone, California, one in Spain outside of Madrid, and one outside of Canberra, Australia. And these systems of enormous communications antennas, one is 70 meters, the rest are mostly 32 meters in diameter. But 70 meters is, almost the size of a football field, right?
That is big.
Yeah. We point them towards New Horizons. We localize in on it, and it tells us where it thinks it is. We tell it where we think it is. And there's this sort of an algorithm that negotiates that. And, based on how we're pointing the antenna and what we knew the velocity was before we first communicated with it. And so we figure it out. And then we can take that velocity vector and propagate it forward and see if it's where we know Pluto's going to be at the right time. And if it's not, then we give the spacecraft just a little puff sideways. Generally, it's not, we won't speed it up or slow it down, but we'll puff it this way or that to change the angle. And then the spacecraft arrives within a kilometer of its intended closest approach point. It's amazing.
Wow. I mean, I'm still blown away by all of that. And the fact that New Horizons did finally get to the planet. I mean, apparently there was a backstory that it almost never made it off the launch pad.
Well, any controversial science mission will constantly have issues, some of which are not technological, some of which are maybe political, about whether or not to continue. And so New Horizons, the journey to Pluto, actually started 9 years before the launch date. And when the team submitted a proposal and it was selected, and then it was terminated, and then it was reselected, and there was a lot of time when the chief scientist, the principal investigator of New Horizons, Alan Stern, was not doing science or mission planning. He was doing political cleanup from some of the problems that it had been having politically. And I'm just extremely grateful to him that he kept the vision all those years in trying to keep New Horizons going, because we would not have known just how amazing a destination Pluto is if he hadn't stuck with it, if his perseverance hadn't continued.
But we've got a bonus, because now that New Horizons has passed Pluto, it's heading out to the Oort belt. Is that correct? The Oort cloud? No,
Kuiper belt.
The Kuiper belt.
Yes.
And what are we expecting to find there?
Well, we now know that the Kuiper belt, which was proposed by Gerhard Kuiper in the 50s, and he passed away before we ever actually found the Kuiper belt. But he felt that if you did the modeling of how the solar system was formed, there should be a lot of debris in a belt somewhere out beyond Neptune. And so when Clyde Tombaugh found Pluto, we just thought it was another planet. In 2006, the International Astronomical Union got together and said, gee, we found close to 1,000 objects out in this belt that Kuiper had proposed. Now we think Pluto is really part of that group of objects.
And hence the demotion, the
reclassification of Pluto.
Oh, sorry, reclassification. You can't say demoting it, because, I mean, to some people in their hearts, it's still a planet.
Yes, yeah. So, the example I like to give, and I'm sure you've heard me give it, is if you were a student, a learner in 1851, how many planets would you have had to memorize? And the answer is 23. And that's because at the time, we were detecting more and more of these objects just beyond Mars. And we thought they were planets. And suddenly, now the telescope got a little bit better, and we were able to figure out that these aren't planets at all. They're not at all like Venus and Mars and Jupiter. They're a new thing. And so in 1852, all of the things that had been called planets before were reclassified as what? Asteroids.
Asteroids.
Yeah. So that's the journey of science, isn't it? You discover something new, you compare it to something you know, and then if it eventually turns out that it's that you've learned something new from that discovery, then you can reclassify it, create a new classification.
But as you would understand and appreciate, 9 years per project just to get some photographs is a long time to wait.
Yeah.
So, but now there's a rather exciting event taking place. We have another New Horizons type project on the go, namely one that is near Jupiter, and one near Saturn. In fact, we've got a couple. Do you want to tell us a little bit about Juno and Cassini?
Yeah. So Cassini has been at Saturn for many years, and the mission has pretty much run its course. You know, we've extended the mission, I forget, 2 or 3 times. So it's performed its primary mission, and then we've done consistently extended the life of Cassini to the point that it is now time to go deep or go in, like into the rings. And that's a journey that Cassini will not recover from. The gravity of Saturn will pull it in, but we will gain amazing science as we go through those rings. And I had the privilege of spending time with my former boss, Jim Green, on Monday, and he was saying that it's stunning, the data that we're getting back. You know, the rings of Saturn are not actual rings, they're spirals, right? And we are learning some amazing things about the ring material, and how I don't want to quote because I might get it wrong, but how that ring material enters the cloud tops of Saturn is not at all what we thought it was. And so there'll be a lot more on that as Cassini takes more data on these final loops into the cloud tops on Saturn.
What is its ETA in terms of arriving gently on the planets?
Oh, well, it won't arrive gently on the planet. It will be crushed in the upper atmosphere.
So it'll actually be destroyed in the atmosphere, not even
correct.
Crash land.
Correct.
And when is that supposed to happen?
I believe it's September.
Okay, that's just around the corner.
It is.
So how long did it take to get Cassini to Saturn? Because Saturn's quite far away.
This is about 4 years.
So that's a lot less than Pluto.
Yeah, you can Google it. I don't tend to remember those little factoids, but yeah, something like 4 years.
And in terms of the time that the data takes to be sent back to Earth, I mean, obviously that because of the distance, you know, it's not easy to send back information to Earth. So if you took a thumb suck, would it be less than an hour, 10 minutes, 15, 20 minutes?
Oh, I'm betting it's about an hour. I used to have that memorized too.
So if Cassini was going to enter the atmosphere, by the time it's taken all its last photos and sent it, we'd have to wait an hour, obviously, or something like that, to receive that information. Is that correct?
So here we go. I just looked it up. The light time to Saturn is 79 minutes. That is from the sun.
Give or take an hour and 20 minutes. That's not bad.
Yeah. That's from the sun, not from the Earth, because the Earth's distance is, you know, changing, is going in and out of phase with Saturn all the time. So, and Pluto, by contrast, is 5.5 hours.
Okay, so that's much longer. I mean, obviously, it must be quite nerve-wracking to try and follow all of that and still be delayed.
Yeah.
Wow. Okay, so now we've discussed a little bit about Cassini, and we've also looked at you know, the fact that New Horizons is now on a new part of its journey, and hopefully we're going to get some exciting information that we didn't know before, or possibly just confirm things that we thought were happening.
I hope so. I mean, every time we go to a different destination in our solar system, we always learn something new. And what amazes me after this long career that I had is just how diverse our solar system is. You know, Mercury is different from Venus, which is different from Earth, which is different from Mars, which is different from the asteroids, different from Jupiter and Saturn, you know, all the way out. And even the moons of the different planets are, you know, why is Europa an ice world with 2 to 3 times more water inside it than the Earth has? And why is Titan a moon, and it's got a hydrological cycle, you know, evaporation, condensation, and precipitation, but it's not water, it's all methane, liquid methane. You know, why? And we don't have answers to those questions, but we live in a rich place for exploration, this solar system. So, let's see, one thing we wanted to mention about Juno. The interesting thing about Juno is it's also making death dives into Saturn, or into Jupiter. So the two gas giants at roughly the same time are getting these highly elliptical measurements, highly elliptical orbital measurements being made of their planets. And the wealth of knowledge that we'll get both from Cassini and Juno, and the ability to compare those two, is historic.
I'm very excited. I think the fact that we've got people prepping themselves for Mars, the fact that we're getting up-to-date data now from planets that are in our solar system. I mean, this is a very exciting time to be a part of the space industry.
Absolutely.
But of course, Mars is still getting a lot of focus, and because it is the Humans to Mars Summit coming up from the 9th to the 11th of May, I want to try and focus a little bit on you involved in some of the missions to send the rovers to Mars, is that correct?
I was, yeah.
And what is the challenge? What is the challenge of getting a rover? Why did they build such small ones? Why not a much larger one? And what was I mean, if you think back 9 years ago, 10, 11 years ago, when they sent New Horizons, the camera lenses and ability to take photos must have been a lot poorer than some of the cell phones we use today. So in terms of the technology of the next mission, I'm sure that they're going to be sending more rovers onto Mars, and they're going to obviously equip it with better technology. What were the limitations of some of the rovers that were sent in the beginning, and did all of them make it?
So all of NASA's rovers have made it to the surface of Mars, which is actually an amazing track record if you think about it. NASA is, I was going to say, at one time, NASA was the only group that had ever landed on Mars. But I think now the British have, but anyway, the point, though, is that we started small, in large part because that's what we could afford. Put an enormous lander on Mars because we would have needed an enormous rocket to get it off the surface of the Earth, right?
Yeah.
So we put a little tiny one called Sojourner, Pathfinder, on the surface of Mars. Liken it to the size of a child's toy, right? Just to demonstrate the concept that you could launch from Earth, travel 8.5 months to Mars, descend through the atmosphere, and somehow land on the surface of Mars. The way we landed Pathfinder or Sojourner on Mars was we used airbags. And then we said, okay, well, now it's time to put some real science instrumentation on these things. And in order to accommodate the science, the rovers got bigger, perhaps the size of a grocery trolley, like a cart you might use in the grocery store. And the technology there was better. We had drills, and we had microscopes, and we had cameras, as you said. We used better solar arrays. We had a bigger wheelbase so that it could go over things better. It was an extension, an advancement of the technology. Well, in addition to this time where we're roving around on Mars, and by the way, these things don't move very fast. If they move 100 meters in a day, that's a lot.
100 meters in a day?
Yeah. And partially because you don't know what you're going to run into, and you don't want the rover to blindly drive into a hole or something like that. So we're very careful. Using a day, that's a lot. Yeah. Oh, is that my friends from Pennsylvania?
Yes, it is.
Hey guys.
Just them.
Yeah. So what we did was we proved again the techniques of roving on Mars. We got some extremely valuable geologic science from Spirit and Opportunity. Those were the mid-sized rovers. And then we said, okay, well, we need to take something to Mars that can search for signs of life. What are the instruments that we need to do that? And when you figure out what those instruments are, that sets the size of the rover, right? And then, of course, there was a long scientific debate, friendly debate over where we should go. Well, should we go here because it's got a lot of clay, or should we go here because the geology looks mostly like there used to be water, or should we go here for some other reason? And so there were several dozen initial landing sites proposed, and they narrowed it down to 2. And then just before launch, they decided they would go to Gale Crater, which has a great deal of diversity. It's got clays, it's got stratigraphy that's out in the open. And so we had this built this rover, which is yet another advancement in technology. Not only from the standpoint of the instrumentation, we're flying in situ measuring devices like a geologist might have in a lab back here on Earth, but also we changed the power system up. So the power system isn't solar arrays anymore. Now it's a nuclear power supply like is on Cassini. Nuclear is probably the wrong phrase. It's called radioisotope thermoelectric generator. But it uses the heat generated from the decay of a radioisotope, and then we turn that into electricity. So, so each time we have this opportunity, we infuse new technology. Like the old adage says, I know you want to ask one more question, but the old adage says, you know, if you always do what you've always done, you always get what you've always gotten, right?
Okay, that's true.
And so the idea of inserting new technology into these missions is paramount if we want to continue to learn about the destinations.
Well, I mean, I'm just thinking, will they be including drones on the next one? Because that means you could send them out and do a little bit more exploration than just the rover itself. And then if it finds something, it could always then change the course of the journey.
In fact, the Jet Propulsion Lab in Pasadena, California is looking at exactly that. How can you make a drone the size of a CubeSat? If you know what a CubeSat is, it's 10 centimeters on a side and weighs less than 2 kilograms, I think. So can you make a drone that's autonomous enough and likely solar powered to fly around out in front of the Mars 2020 rover? They're looking at that right now.
Wow, yeah. That is very cool.
You gotta understand the Mars atmosphere is, I think it's 100 times thinner than the Earth's atmosphere.
So that makes drones a little bit more challenging to work with.
It does, doesn't it? Yeah, the change of you have to change the propellers around quite a bit, and don't get quite as much lift as you do here. Well, you're gonna get 100 times less lift, I suppose, than you do here on Earth.
Okay, well, I can see that Mr. McNulty's got some people in his class that are eager to ask some questions. So sure. Let's switch over to Mr. McNulty. You want to ask your students to ask their questions so they don't have to type it?
Sure. Let's see here. Could
Oh, he went on mute.
You've muted yourself. You're going to have to unmute yourself there for a second.
Can you hear us now?
Yeah, now we can hear you.
Have you been to space before?
Oh, no, I haven't. No. I'll leave that to the astronauts. I'll stay on the ground and work on the technology to help them get there safely and return safely.
That's a good question. Would you want to go to space?
I don't think I think I'd like to wait.
A very diplomatic answer.
I think it would be fun to float around, but I'd like to feel confident that I could get back safely. Safety is NASA's first priority for everybody, not just astronauts, but anybody who works on the NASA project. But of course, bringing the astronauts back safely, that was part of Kennedy's original direction when he sent us to the moon. And it remains a part of our culture today. Space remains a hard thing. Space exploration, space science, those are all difficult things, but they're worth doing. And so perhaps you'd like to be an astronaut someday and help us make space even safer.
That's a very good idea. Any other questions? Fire away.
I'm
You're gonna have to-
Bella.
yep.
This is Bella.
Hi, Bella.
Hello, Bella.
How hard is it to make the technology to get rovers onto like Mars and the moon?
Yeah. So the best way to answer that question is just how long does it take to work on a mission like a Mars rover? And I can tell you that the rovers, we tend to work on between 8 to 9 years, 8 to 10 years before they're ready for launch. And sometimes they actually miss the window and have to wait about 26 months in order to go again. But a typical spacecraft, one that might go into orbit around the Earth, is usually about a 4-year period before they're ready for launch. So that kind of gives you the idea of just how long we work on these things to assure that once they get that far away, they're absolutely going to work and be safe. That's a great question, Bella. Oh, look, they're lining up.
I know.
Absolutely.
This is a Reed, right?
Yeah.
Go ahead, nice and loud.
I was wondering if you knew how many light years away the Pinwheel Galaxy was from the Milky Way.
Which galaxy?
The big wheel.
See?
The big wheel. No, you know, you're going to have to Google that yourself.
I think that's fair.
Yeah. I mean, Jim is all-knowing, but he does have outer limits, apparently.
I tend to think in terms of, because of my background in planetary science, I tend to think in terms of light minutes and light years, or light hours, not so much in light years. But I know, you know, the recent find of exoplanets around the TRAPPIST, or in the TRAPPIST system, that's 39 light years away. And so we did some quick math, and you can do it too, maybe confirm the calculation. Pluto New Horizons was the fastest object ever to leave the Earth. We Googled how fast it was moving when it flew by Pluto. And the planets, the exoplanets around TRAPPIST are 39 light years away. So that means that it takes light 39 years to travel between our star and their star. New Horizons wasn't traveling at the speed of light, and it's something like 1,500 years traveling at the speed that New Horizons was traveling at when it flew by Pluto in order to get from here to TRAPPIST. So
Sure. That is huge. I see you have another question.
Go ahead.
I'm Carly, and
Hi, Carly.
I was wondering if humans, with the right technology, will we be able to live even for a week on Mars?
Absolutely. That's the plan. And that's why investing in the technology is so important. Everything from how do you make a habitat that you can construct on Mars, because you know you can't just walk out in a shirt sleeve environment. And Steve, I do want to talk about Mars climate at some point.
Yes.
If we got the chance. All the way to how do humans rove on Mars? How do you walk and move around? What do you do? The technology necessary to use what you find in place there. Right now, we believe there's a lot of CO2 and a lot of water. The water's in the form of ice, and CO2's in the atmosphere. What can you do with that? Well, you know, you can make rocket fuel out of it. So we need to find ways and the technology to be able to do that. So those are challenges, but yes, the plan would be for astronauts that go to the surface of Mars to stay there from something like 18 months to 2 years before they actually come back. So,
Whew. So that's a lot longer than a few days.
yeah.
Okay. Next question.
What do we got?
Go ahead and introduce yourself.
I'm Gabby.
Hi, Gabby.
Hi. Why is Pluto not considered a planet anymore?
Oh. Well, let me ask you: is Pluto a planet?
Anymore.
No.
No. So we were talking about this, I think, before you all dialed in. If you were in school in 1851, how many planets would you have had to memorize? You want to take a shot at that, Gabby?
I don't know, like 20.
Oh,
She said 20.
closest anybody has ever gotten.
That's not bad.
It was 23.
Oh, wow.
And the reason was because when we would discover something in the night sky in the early 1800s, we would say, just like any scientist, well, what is this? And it must be something like I already know about. So they would classify this new discovery as a planet. Well, in 1852, the telescope had gotten incrementally better, and they were able to resolve the fact that these things in the night sky that they were seeing were not at all like Mercury and Venus and Mars and Jupiter, but they were actually something different. They were a totally new categorization of stuff, and those are called the asteroids. So in 1852, they took out all of the asteroids, and we were left with 8 planets. Then along comes Clyde Tombaugh in 1930, I believe, and he was looking at the night sky, and he found this object that wasn't cataloged as an existing planet, but it was clear it was moving like a planet, and so they called it a planet. They named it Pluto. Over time, our ability to explore that region of space with telescopes, we found an area of space called the Kuiper Belt, and now we found over 1,000 objects that are friends of Pluto, if you want to call them that, or Pluto's family. And so in 2006, not NASA, but the International Astronomical Union met, and they said, okay, what makes a planet? And what they said was, it needs to be in a circular orbit around the sun. It needs to clear a path, clear debris out of its way as it's been formed, and it needs to be roughly spherical. Well, and circular in the sense that it doesn't cross the orbit of another planet, right? Well, it's that last rule that Pluto seems to have broken. Pluto crosses the orbit of Neptune, or you could say Neptune crosses the orbit of Pluto. But the bottom line is it didn't meet the criteria, and there are these 1,000 or so other objects out there that look like Pluto. And so they had a vote, and they decided. In fact, there's a neat YouTube video of the vote actually happening. They decided that Pluto was now to be called a Kuiper Belt object or a dwarf planet. My understanding is that because of all of the information or everything that we learned about Pluto when we flew by it in 2015, that the IAU will take up the question again the next time they meet about whether or not Pluto should be reclassified back as a planet. So we'll see how that goes. It's all about the scientific method and learning and deciding what it is that you've learned.
So are you saying that Pluto might be making a comeback?
Oh, yeah. You want to start a campaign?
I don't know. I see some more questions. I love it when you guys have got questions. I'm happy to sit back and let you ask questions.
We're ready.
Hi, I'm Ashley, and do you think, we already know we can live on Mars, possibly, are there any other planets or moons in our solar system we might be able to inhabit?
Yes, yeah. I think that the next destination in our solar system would be a moon of Saturn called Titan. And you can Google that. Titan's an interesting place. The water on Titan, it's so cold that the water on Titan is frozen like rock. And it has the right temperature and pressure to have a hydrological cycle. So there is actually liquid on Titan that evaporates, condenses in the clouds, and then precipitates. But it's not water, it's actually liquid methane. And when you do the math, you figure out that the raindrops on Titan, given the density of the atmosphere and the gravity, the raindrops on Titan will be as big as your fist. So it's an interesting place. But that would be a destination where we could send human beings, possibly, after we figure out Mars. Another destination is a little closer to Mars, Phobos and Deimos, the moons of Mars, would be interesting places to visit as well. So
I know a couple of people that I'd love to send out there now without the technology, but that's besides the point. I see we have some more questions. Don't be shy. Push her in front. That's the way to do it.
What do you think the furthest planet we'll ever be able to travel to is?
Okay, you were speaking pretty softly, and your microphone didn't pick you up. So can you say that again?
What do you
Gadget voice.
What do you think the furthest planet we'll ever be able to travel to is?
Oh, so
Furthest planet.
yeah, the furthest planet for humans to travel to. So I think that given the right amount of time and the continued evolution of technology, that we'll go beyond our planets, that we will actually someday find a way to get all the way to the TRAPPIST exoplanets, which are, I mentioned earlier, 39 light years away. It's just a matter of time and perseverance. So will we travel to Pluto to stay? Maybe, maybe not. You know, it really depends upon what our intentions are by the time we've developed the technology to send people out that far into space.
Sure. Now, before we have the next question, just to acknowledge, we have a lot of viewers from around the world who are watching live on the Living Maths website and also via the YouTube. So we say hi to all of you. And these are obviously some of them are classes that are streaming it, and they haven't actually joined the live hangout, but they're actually watching it in their classrooms, which is pretty cool. I see we have some more questions.
So, Steve, before you do that,
Yeah.
can you pull that graphic up that I sent you?
I can. Let's see if technology is behaving itself. I'm going to try and share the screen.
This is a map that you could probably find on Google somewhere on a NASA website. So there's nothing terribly special about the map. But what I wanted to show you, this is a false color image because the blue are low-lying areas, areas where you might call it below sea level, although there's no ocean on Mars. And the red and white are very high, like peaks and mountains. And you can see we've been consistently exploring what is essentially the shoreline of Mars by looking at all of the destinations where we're sending these things. Lately, people have been concerned about climate. And one of the really interesting things that's happening is we are beginning to learn about Earth by studying the climate of other planets. In fact, Jim Hansen, who helped define the hole in the ozone layer on Earth, found it when he was studying the atmosphere at Venus. So there's this crossover that's beginning to get recognized about the study of climate between the various planets. One of the things that holds our oxygen, our atmosphere in place, is the fact that Earth generates its own magnetic field. Mars doesn't have a magnetic field anymore. We've been able to detect the fact that it has had at one point in time a magnetic field, but it doesn't anymore. And so we sent the probe called MAVEN to measure the upper atmosphere at Mars. And one of the more recent science results is that MAVEN has detected that Mars is still losing atmospheric oxygen from the planet due to the solar wind. So if there's no magnetic field, then the solar wind from the sun moves forward and it just slices off the upper layer of molecules of the atmosphere. And that's how we think Mars lost all of its oxygen. I'm looking up a factoid here, see if I can find it. Hang on one second. At this time, we believe that that Mars is losing oxygen at a rate of 1.5 kilograms per second due to the solar wind interaction with the upper atmosphere. So there's no magnetic field to protect it, so the atmosphere of Mars is like this, and the solar wind comes along and just slices off the top. 1.5 kilograms of mass lost every second, right? We're safe on Earth because we have this magnetic field. So we have an atmosphere, and the solar wind comes along, and the magnetic field is out in front of the Earth. It deflects the solar wind, and the solar wind goes around the Earth instead of over the top of our atmosphere. And these are things that, by looking at other planets, we can make comparisons about what's going on here on Earth. The main reason I wanted to show you this, though, that I got really excited was I asked Jim Green, well, why, what happened to Mars's magnetic field? And he said, we think it got interrupted by some sort of cataclysmic event. You know, like we had an asteroid that came and hit the Earth, and we think it threw up all this debris, and that's how the dinosaurs became extinct. Well, it turns out that big blue dot in the middle of the picture there, that's Hellas crater. It's the deepest place on Mars. And we think that Mars was hit by an asteroid in ancient times, and that interrupted the flow of the liquid at the center of Mars's core in such a way that it's not producing a coherent current any longer, and therefore, if you don't have a current, you don't have a magnetic field. But the really interesting thing is the way this map is laid out. This is the whole surface of Mars, if you could unwrap the globe and just lay it flat. Exactly opposite the surface of Mars is the highest spot, Olympus Mons, on the surface of Mars. And so what the scientists are thinking is, when Mars was just being formed, it was still just a little soft, a little squishy. It got hit by this giant impact, a meteorite of some kind, and it made that impression, and the shock wave went through the planet and came out the other side, and that's why you're seeing the high peaks on the left-hand side. They think that maybe that's what interrupted the magnetic field on Mars, and then immediately it began to lose its atmosphere due to the solar wind. Okay,
Sure.
That's what I wanted to say.
That was a good one, but I see we got more questions, and they just want to fire away.
Sure, go ahead.
Hi, Mr. Adams. My name is Charlotte.
Hi, Charlotte.
What type of materials would you need to use to build like sustainable structures on Mars?
Yeah, lightweight materials, materials that you can construct with. You know, NASA, when we send stuff into space, we tend to use aluminum because it's light and it's durable, and it conducts a little bit of electricity, which is useful. But when we get to Mars, we have to take all that stuff with us, and I forget the wheel ratio, but it's something like for every kilogram we land on the surface of Mars, we need 16 kilograms of rocket fuel on Earth to launch it. And so you can imagine that not just from a cost standpoint, but from the price you pay for rocket performance, it becomes really difficult. So we're looking for something lightweight. And if you saw the movie The Martian or read the book, the author there thought, well, you know, maybe we'll use inflatable structures. Well, he's not too far off the mark. If you look up the inflatable structure that we've just flown to the International Space Station, we're trying it out there to see if we might be able to use some sort of reinforced fabric structure, not only in space, but also on the surface of Mars. So there you go.
Thank you.
And fabric would be important. I mean, you got to look good as well. And if you've been watching the series, Mars series, and if you've been watching the National Geographic Mars series, I mean,
yeah, amazing.
That's been amazing to see the outfits and also to see, you know, how they envisage we would be tackling the whole Mars issue in 2030.
Yeah.
Did you say it was 1 kilogram or 16 kilograms of fuel to put 1 kilogram on Mars?
I believe that's correct. Yeah.
Wow.
So it's of that, Mr. Rinaldi, it's of that order. I wouldn't put that on a science test.
Okay, so approximate. Good question. Good question. So, I mean, I know that we still got a few more questions there, and I'm not sure if we're going to have much time, but there were one or two issues that I wanted to ask that I think that a lot of people are perhaps overlooking, and that is, if I land on Mars, do I own what I find? And if the US or a group of people land on Mars, who owns what they find? And could I start mining for various precious metals and stones, and who would get to own that?
Yeah, good question.
Great answer. I love the way
the International Space Treaty that's signed by most spacefaring nations says that everything out there belongs to everyone, right? But what does that mean? If you were just to go to the moon and pick up rocks and bring them back, do you have the right to sell them? Nobody knows the answer to that question just now. And there are whole companies being formed specifically to try and figure out how to mine asteroids and then resell the riches that they think they're going to find in asteroids. So nobody's really sure, and we won't really know until somebody tries it, and there's a test case that goes through a court of law, right? Because we're not really sure what private individuals, what the role of private individuals are, and what the rights of private individuals are as as space gets opened up to everyone. You know, we have these treaties that are signed between countries, but does that mean that Steve Sherman Space Mining Incorporated has to follow them, or can he go stake a claim at Olympus Mons and begin mining?
If I found a planet that you guys hadn't visited, and I was the only one who found the planet, and it happened to be covered in diamonds, and every rock and boulder was the size, I mean, ginormous. I mean, there's obviously a lot of incentive for me to benefit from that without anyone else taking what I've found.
Well, certainly, I'm sure you would feel that way.
but as you can, that's where the complexity comes in.
I'm not so sure the United Nations Committee on Peaceful Uses of Outer Space would feel that way. So we'll have to see.
But you said only the people who are part of that committee.
That's true.
What happens if I'm a rogue and I come in with my own technology and, you know, I invent my own electric cars? Because, you know, us crazy South Africans, we tend to create companies like that.
Well, so then you get to be Luke Skywalker working for the Rebels, and I'll be Darth Vader working for the Empire, all right?
That seems reasonable, especially on May the 4th, which is Star Wars Day. So now one of the students that I was teaching today said, please, you must ask Jim, how did you get into doing what you do?
Oh, yeah. And Steve, you know this story. But
I do, but for the people out there, give them a shortened version of what is it that you did to get in here?
In the mid-'70s, when I was in university, I was studying physics. And in the physics lab, we had an electronics laboratory, and I was playing with microchips. Microchips had just become useful. They were nothing like the microchips you see today. If we had 4 logic gates on a chip, that was a lot. It was a really big deal. And so, but I had used them to control experiments, to track satellites and that sort of thing. And I started thinking to myself as I got to the end of my diploma, what am I going to do when I get out of college? And just down the road was a company that made cash registers. And in the 70s, 60s, 50s, and earlier, the cash register was a mechanical device that looked a lot like a typewriter. And you push a button and a number would pop up on a screen, and you push another button, it would add that number together, and then the drawer would open and the cashier would have to take your money and count change back to you and that sort of thing. But it was a way of keeping track of how people paid for stuff. Today, those things are totally electronic, if they exist at all anymore. But back in the 70s, I thought, oh, you know, those mechanical things, they're going to become electronic, and I would like to design cash registers for a career. And so I applied to work for a company in Ohio that made cash registers. And the first career mistake I made was not realizing that they would be hiring electrical and electronic engineers, not physicists. So I ended up having to go with my second choice, which was as a radiation hardening engineer working for an aerospace company called General Electric. And I went to work for GE, looking at the effects of radiation in space on materials. And that's how I got into aerospace. And then over time, I ended up working on the design of the International Space Station, and NASA offered me a job and I took it, and that's how I ended up working for NASA.
So would you say that math, science, problem solving are important when it comes to anything like this?
Anything from cash registers to aerospace. Yeah.
Awesome.
Yeah. Or for that matter, you know, even if you want to bake cupcakes for a living, you still have to be able to think critically, logically. You have to be able to add a column of numbers together and do fractions and maybe even a little differential equations every now and then. So, you know, my advice to everyone in the time that we have left is stay in school, study math, study science, because you just don't know where it's going to take you. It could take you all the way to Pluto.
Now, I know that we're technically supposed to end, but I can see people are itching to ask questions. So, Jim, have you got another 5 minutes?
5 minutes, and then I got to go. I've got another call.
Jim's just an important guy. So, Mr. Guptill, is anyone in your class there that wants to ask a question? So he's just going to unmute himself. We've got no sound there. Oh, there we go.
Yeah, he's off.
Yeah, they just walked in, so they're still trying to catch up on the conversation. I was just telling them, you guys, that you were discussing Mars. So I don't know if they're going to be up to questions.
Okay, no problem. I can see that, but Mr. McNulty's definitely got some people that want to ask 1 or 2 questions. So we'll give you 2 more questions, Mr. McNulty.
Make them good ones.
Go ahead, you're first.
My name is James, and I was wondering, in 500 years, do you think we'll colonize Mars?
Oh yeah, I think it'll be long before 500 years. I would say the next 20 or less. And
wow.
But I will tell you, James, I don't like the idea of colonize, because that has sort of an exploitive nature to it. I think we'll settle on Mars. I think there'll be families and societies that will start to grow, especially in 500 years. Yeah.
And I mean, there is a probability that maybe some of the pioneers will be sitting in the classroom with Mr. McNulty right now.
Absolutely. Yeah.
That is cool. And I see we have one more question. Someone who's got just the right hairstyle for Mars.
Okay, I'm Bella again.
Bella?
And do you think there will ever be a way to like create an artificial atmosphere for different planets that do not have atmospheres?
Terraforming Mars. Wow.
So
That's
Bella,
a good question.
that's a really interesting question. And so one of the thoughts about what to do, how might we make Mars more livable, is maybe we could help it create its own magnetic field so it doesn't lose oxygen at the rate of 1.5 kilograms per second, right? And so there are some concepts out there for how we can encase Mars in a magnetic bubble sufficient to allow the atmosphere to be retained. And when you retain the atmosphere, then the heat that's generated at Mars will stay with Mars. It'll start to warm up, and we think then the water ice will begin to melt. And so it's entirely possible that we could come up with the technology necessary to transform Mars. Venus is a little harder. Venus is a really hostile place. But those would be the two places I'd start looking at, or one of the moons, like I mentioned earlier, Titan, or Enceladus, perhaps.
That was a great question. So now, Jim, we've run out of time, and I know you've got lots of appointments and things to go to. What is your final parting bit of advice for any young people out there that would like to get involved in the space industry, that would like to learn more about Mars or get involved with NASA, that type of thing? What sort of advice would you give them?
I would say keep studying, stay curious. There's all kinds of things happening around us today. We live in an amazing time where space is beginning to open up to anybody. You know, high school students, junior high school students are building CubeSats that are flying to the International Space Station, and the astronauts are throwing them overboard. You know, so you could get your experiment flown in space before you graduate from college.
That's amazing.
It is stunning. This August, if you're in the United States, August 21st, a total eclipse of the sun. Learn more about that. You know, go to eclipse.nasa.gov. There's a wealth of information about how the sun interacts with the moon and the moon with the earth, and what that eclipse is going to be like. So there's all kinds of things that you can do.
If I recall correctly, a colleague of mine, Jeff Bennett, who has written a couple of books, he has created an app to help people locate the eclipse from wherever they are in the US. And you'd have to search for Big Science Eclipse app on iTunes or the Play Store and all the various places, so that if you're sitting at home, it will actually show you where to look and what to do when it comes to the eclipse. And you mentioned that NASA has brought out some lovely booklets and things.
Yeah, so this is I'm not plugging this, but NASA, maybe Mr. McNulty or one of the other teachers, if you write to NASA, they'll send you a teacher's kit about how to instruct your students, not only about the science of the eclipse that's happening in August, but also safety, how to look at it safely and how to talk to your friends about it. So.
Well, we have run out of time. So Jim, I'm going to say thank you very, very much. I'm hoping that we will be seeing you very soon. Jim is certainly no stranger. Yeah, I know.
On Monday. But I'll only be there for 4 days, and it'll be in Johannesburg. So.
But you won't be coming down to Cape Town. But I mean, Jim is no stranger to South Africa. He comes down quite frequently, and hopefully we'll have him out later on this year, because we would love to do some school visits and travel around the country. And of course, if any of you guys are interested in having Jim come and speak to you at your schools, you're welcome to make contact with me, and I'll send you all the details. And of course, we had Jason Guptill, the teacher who showed us Live Long and Prosper, but that was the wrong franchise.
That's
it should
okay.
be May the Force be with you.
It's all one.
It is. And to all of you that joined us, thank you so much for our live viewers. We've got lots more of these interviews coming up over the next week. And to those of you that are interested in finding out more about the Humans to Mars Summit, please contact us. We'll send you information. We might even be able to organize you discounts to go if you are in the US and would like to meet all the big names in the space industry. I do know that Buzz Aldrin and Bill Nye and all those sorts of people will be at the Humans to Mars Summit. So on that note, Jim, thank you very much. Jim, can we ask you to do one big smile so we can get a screenshot of you? That's a good one. And now a real smile so we can get a nice screenshot.
Now I need my Darth Vader mask, right?
Oh, there we go. We've got the hands up in the air. That's perfect. And to Mr. McNulty, thank you for joining us in your class for very good questions. Those were outstanding questions. Bye-bye, everyone. We're going to end the broadcast here.